Hi, I'm Kim Combs. What's your favorite holiday? Mine is Independence Day, without a doubt. Every July 4th, people all across the United States celebrate our nation's independence. There are picnics, barbecues, and parades, all capped off with fireworks. For as long as we've been a nation, we have celebrated important events with fireworks. But fireworks were used in celebrations over 1,000 years before America's Independence Day. The Chinese are credited with inventing fireworks sometime between 600 and 900 AD, after a Chinese cook is said to have mixed 3 common ingredients together, creating gunpowder. Today's fireworks displays are often like well-choreographed ballets with music, colors, and explosions working together to create a spectacle for the eyes and ears. So what's chemistry got to do with 4th of July fireworks? Let's talk to Dr. John Conklin, a fireworks expert, and find out.
Well, fireworks start with chemistry. The fireworks chemist designs mixtures to produce a beautiful red flame or beautiful gold sparks, but then turns that over to the fireworks artist, who turns it into the beautiful patterns that we'll see. So fireworks are a combination of science, chemistry, and art to produce the beautiful effects.
Fireworks wouldn't be nearly as impressive without the amazing colors. How are the various colors achieved?
We achieve colors in fireworks by adding specific chemical elements to our burning mixture. The properties of certain elements like strontium, heated to high temperature in a flame, involve getting rid of that energy by emitting very specific colors of light. In the case of strontium, a beautiful deep red color. Barium will give you a deep green color. So we produce the color effects by adding very specific elements to our burning mixture. The hardest color to achieve in a fireworks flame is blue. We can make red, we can make green, we can make orange without too much trouble. Blue has eluded fireworks manufacturers for centuries. Copper compounds produce the best blue that we have to date. We're fair with blue. It's the holy grail of fireworks to try and make that beautiful blue flame.
As a matter of fact, the various substances that fireworks are made of are represented on this table. Let's find out which elements are used by firework manufacturers.
A fireworks show is a real illustration of the periodic table. We use a large assortment of elements to get fireworks effects. Strontium for a red flame color, barium for a green flame color, copper to make a blue flame, sodium to make a yellow-orange flame, titanium metal, little granules of titanium to make beautiful white sparks, aluminum and magnesium as fuels to help give us a nice high flame temperature, chlorine to help enhance our flame colors, and potassium as a component in the oxidizers that we use to make fireworks.
The colors and flames are produced when an excited electron returns to its lower energy orbit. As it returns, the electron emits a photon. We can see the photons emitted in the visible light spectrum. Let's look at hydrogen as an example. Hydrogen contains 1 electron. When the electron is excited to the 6th energy level and returns to the 2nd energy level, it emits a photon. Since the electron is dropping 4 energy levels, it releases a photon with more energy and a shorter wavelength, which produces a purple color. When the electron is excited to the 5th energy level and returns to the 2nd energy level, it emits a photon that produces a blue color. When the electron is excited to the 3rd energy level and returns to the 2nd energy level, it emits a photon which produces a red color. But color isn't the only consideration when creating a firework. Shape is also an important element of a firework display. How are various shapes made?
We make shapes in fireworks through engineering. The chemists will design the color mixtures that are made into pellets. And we have a hemispherical container, and we place these pellets into that container in a very specific geometric pattern, like a heart or a star. And we very carefully pack a bursting charge, an explosive charge, around those pellets. So when that shell bursts up in the air, stars spread out into the sky in the exact pattern that we had them packed into the container. A lot of trial and error, but when it works, you get a beautiful heart or a star up in the sky. You get more oohs and ahs than you get with almost any other fireworks effect. What we may see in the future with fireworks will be better patterns, more elaborate patterns up in the sky through the engineering and packing of the stars in the specific ways. The other thing we hopefully will see will be letters. Ideally, someday we could shoot 4 or 5 shells up in the air. They'll burst and actually spell out a word.
Wow, shapes and words? Now that would be very cool. The last element of a fireworks display is the noise. Booms, whistles, bangs. They just don't happen. They are as equally designed as the colors and shapes.
The loud boom is produced by causing a fireworks mixture to explode in a tightly sealed container. We seal the mixture up, it ignites and burns, produces a high pressure, and bang, it ruptures the container. The whistle is a totally different effect. It's pressed in a tube, a very thin tube, and it burns in a cigarette fashion from layer to layer and pulses gas out the top of the tube at an audible frequency that we hear as a screeching whistle.
There are many events at which fireworks are used. Boston's 4th of July fireworks display has long been considered the nation's premier event, orchestrating fireworks with live music. But no matter the size of the event, we are fascinated by the sights and sounds a fireworks display offers. See you next time.